to be talking about AI/ML workloads with Flux. And if you know this particular song, I'd like you to repeat the next phrase after me. I need some audience participation here. I like to Kube It. You like to? Nice job! Alrighty, let's get started. So I'm the same person as I was before, no surprise there. You already know you're in the tutorial or the project day for Flux Framework. I want to bring up this slide again because I want to point something out. So when you're running in the cloud, what's the biggest difference in your mental state when you're using cloud GPUs? Well, does anyone want to offer an example of what are they feeling like when you're bringing up a cloud GPU? Yeah, that's exactly right. So you're usually more aware of the cost of the cloud GPU than when you're running on premises. This is especially true for me. And so in this case, elasticity and dynamism becomes really important because as your workload changes over time, or maybe you start with a small number of nodes, you scale up and you scale down, when you no longer need a set of nodes, you want to be able to release them because you're not paying for them. And so this is why this particular example for Flux to have dynamism is really important in the cloud. So as an example, in the cloud, you may bring up a cluster that starts with a particular number of GPUs. You then scale up, you add nodes because you're training, it's getting larger and bigger, you're PyTorching away. And then when you're done, oh, I went the wrong way. When you're done, you release them, just to belabor that point. Alrighty, and I already kind of said this, but what's really interesting about Flux is that it's analogous to Kubernetes and that it's modular. And actually what this slide does a better job at is it shows the different components of Flux. So Flux core is, not surprisingly, where a lot of the core stuff is, messaging, and actually I don't need to get into that. Who wants to guess what Flux Get is? Scheduling, yes, okay. Flux Security is a little project we have for security. Accounting is maintained by Chris over there. He does a great job. That's for accounting stuff, user queues, that kind of thing. And I think we've talked about Flux payment. Anyway, in Kubernetes, there's always, well, not always, but there's usually an analogous kind of component. And I already talked about converged computing. Let's not belabor that point. So if you're like, I want to run HPC in the cloud, what are my options, Vanessa? Well, I guess the first logical question is, do you want to Kubernetes or do you want a virtual machine? So if you want a virtual machine, which is kind of closer to, I always say kind of bare metal, you know, with the air quotes, because it's not exactly bare metal, but it's kind of close. We actually have Terraform recipes that will allow you to deploy it within actually a couple minutes. So in AWS, Azure, and Google. In AWS, you get the Elastic Fabric Adapter, or EFA, which is very good. I also will say their HPC family of instances are really awesome. My favorite are the Graviton HPC 7G. And actually, Evan's in the room, and there's now an HPC, what was it, an 8A? An 8A. I haven't tried it yet. I bet you it's awesome. We're actually going to be using 6As today. Azure has InfiniBand, so that's very HPC-like. You can use AKS with VM sets. And then Google has tier 1 networking, probably the least HPC-ish type network, but it's still pretty good. So we have recipes if you need these on GitHub. Poke me if you want to get an exact GitHub URL. I already talked about the Flux Operator. Whether you're a Kuber noober or a Kuber nodder, or a Kuber just haven't tried it yet, you can try out the Flux Operator. It's really easy to deploy your entire mini cluster. We're actually going to be using the Flux Operator today. Here is some new kind of exciting news. So who is familiar with the Kubeflow family of projects? Raise your hand. Okay, that's pretty good. So I'll kind of explain what it is. When you want to do machine learning training in Kubernetes, it used to be that you picked a specific operator. So an operator is like an application that you deploy in Kubernetes. It kind of it basically allows you to write a YAML file that's like, hey, Kubernetes, this is the state that I want you to be in. I want you to create these pods. I want you to create these services. The operator does something called reconcile, where it looks at the state of the cluster, it looks at what you want, and it makes incremental changes until what you want is the state of the cluster. So it used to be the case that like there was a PyTorch operator, there was a Ray operator, and you would pick these specific operators. the Kubeflow community came along and they were like, hey guys, we should make a common project for these different machine learning training projects. So this project is called the Kubeflow Trainer, which makes me think of sneakers, but it's training and machine learning. And we had this idea, we're like, if we add Flux to the Kubeflow Trainer, that means that you can do workloads that combine AI and ML with simulation. And so this is actually a newly released, like fresh off my programming fingers last week, integration into Kubeflow. It allows you to do these things I just said. If you have, for example, CPU-bound tasks. Before, okay, who has heard of the MPI operator? Anyone? Not just a couple? Okay. So before the MPI operator was kind of the bread and butter that you would use for MPI, it was missing a few features, a few MPI variants, PMIX, so Flux improves upon that. So if you want to try, actually we're going to be looking at this today, so we'll take a look at this later. Okay, so here's some really cool stuff. Tom kind of mentioned it earlier, but I will talk a little bit about it. Agentic science, basically using LLM models as brains to then do some kind of, of agentic science. I guess I shouldn't use the definition in the term, but basically, if you have an agent, so this LLM model, that you want to interact with Flux, well, we have Flux that is basically provisioned with MCP. So I kind of talked about this in my talk, but I'll mention it here. I believe maybe that agents are going to be central to this HPC center of the future, really an active participant, not just in kind of orchestrating your application work, but also in kind of core center functions. And the basic idea is that they need to be empowered to kind of gather, interpret data, discover things, to execute tasks, use models. And here's the challenge. So who has in their HPC lifecycle tried to deploy some kind of service, like with an open port in their cluster? Not a lot of people. So if you haven't tried this, depending on the center that you're at, it's very hard. Some centers kind of let you do it under your job. Some centers absolutely not. You'll need to go through 6 months of security audits to open a port. So like this kind of service is not really friendly with HPC. They're kind of allergic to each other. So the question is, where are you going to run your MCP server? There's kind of 3 places. You can run it under the context of a batch job, maybe for your application. You can run it on the level of your cluster. Maybe your HPC administrators are maintaining it. This might be, for example, where you run like a multi-tenancy Flux MCP server. You could also run it above your cluster. For example, if you want an agent that is going to choose which cluster to dispatch to. And as you increase up this levels, you'll see an increase in complexity and security. That's probably more so to think about if you're deploying them. We don't have to talk about it here. MCP is the Model Context Protocol. It's basically this idea that you have these 2 pieces. You have the user in blue with this cool little hat that has a particular goal. I want to do this thing. And then you have your agentic framework that is going to basically be the brain that tries to incrementally do work to get toward the goal. And how is it orchestrated? It is orchestrated by an agentic framework, which is nothing more than a design philosophy about how basically you're going to be making calls to, for example, your MCP server. Okay, so here's a quick summary of some of the tools we're working on. We already talked about Flux MCP. Those are the functions for Flux Framework. We have another library called HPC MCP that's kind of a grab bag. It has SPAC, it has Docker, it has file system, it has a few Git, it has Kubernetes. Anything that I need that I can't find, I put in this library. The ones that are under Flux MCP are basically what you'd expect for Flux. So what I talked about in the first tutorial, submitting jobs, monitoring jobs, canceling jobs. You want your agent to be able to do those things. We actually have some Flux Sched tools too, although we haven't used them for anything yet. Okay, so let's get into the tutorial. What are we going to be learning today? We're going to be deploying the Flux Operator to Kubernetes and running an HPC workload. I actually think we're going to be running PyTorch and maybe some lamps. We'll look at interactive and automated. We're going to check out the Kubeflow Trainer, hopefully in two contexts, if I can connect to the AWS clusters from here. Then we're actually going to take a look at Flux MCP, and this is going to be the scariest part for me because I do not know what the agents are going to do in advance. So, give me a second. This is going to be another issue of like, is this terminal look okay? So let me make sure that what you see. Okay, what does that look like? Is that like huge? Is that an okay size? Does that make sense? Yes? Okay, of course now this is huge. Hold on. Okay, so this is, let's see, how can I do this? Is there like a mic holder I can use? Audio visual people? Or do I have to hold this? Yeah, I'd like to have both my hands to use the keyboard this time. Yeah, thanks. Alrighty, so, can you hear me okay? Yeah, I can hear myself, I'm pretty darn loud. Okay, so what we have here, kubectl get nodes. We have two nodes on AWS. These are HPC 6A nodes, so they're optimized for HPC. And what we're first going to do, and actually I kind of already did this, but when you, Flux Operator, this text is really huge for me. Let's see, when you install the Flux Operator, you just apply a manifest from GitHub. I actually have it right here, so I would have just done kubectl, apply F. F means file, fluxoperator.yaml. That's going to just run, and basically it says unchanged because I already installed it and nothing is changing for that particular thing. And then what I'm going to do is you usually create a mini cluster. So I actually already did this so I could create the thing, the mini cluster. So let me just give you an has anyone in here never seen a Kubernetes manifest? Okay, that's enough people that I'm going to kind of walk through this. So when you look at a Kubernetes manifest, you have an API version. This is saying, okay, this is fluxframework.org, it's version 2 alpha. The kind is like what abstraction in Kubernetes you're making. So this is a mini cluster, this could be a pod, it could be a job, it could be a PyTorch job, it could be a train job. Metadata is like name. It also could have a namespace, so Kubernetes basically doesn't have like UIDs. The way that it controls permissions for things is with something called resource-based access controller, RBAC, and that's usually associated with namespaces. So you may have permission to create something in a particular namespace. The default namespace is called default. So the way that one of these specifications works is that there's always like a spec. And so under the spec, the designer of the operator gets to decide what parameters they expose. So what I designed this operator spec, so what I expose is basically a list of containers. So this is saying like, okay, I want to run a PyTorch container. Launcher is a trivial detail I don't need to go into. And the launcher container is actually going to start an MCP server. So this is a server that is basically provisioning different tools. It's going to expose it to kind of the port, and it's going to use a configuration file that defines a bunch of Flux functions in it. So I wonder if we can see that if we do kubectl logs, PyTorch 0, and if you want the log to stay hanging, you add the F. And so if we do that, oh, look what I found. I found our server, and so notice how it's hanging. And so this is the MCP server. Actually, I can show you a couple of things here. If you're interested, a lot of the metadata up here is basically Flux starting up. So it's like, okay, hello user root. By the way, the Flux operator does support running as a single user because we run it on our a type of storage node called a rabbit node. But right now we're running as root because we're living dangerously. The zero, a lot of the handshakes, we use a curve certificate for security, which I usually wouldn't show like that. This is generating the resources. This is just some helpful stuff, like here's the flags. Here's how we're starting. This is traditional when you do like a Flux broker start or Flux start. Here's the actual thing that's running. This is the MCP server. So these are all of the functions that we're going to be giving our agent. And specifically, here are the functions that we're giving for Flux. Now, if you've never done MCP before, this server exposes an endpoint called list tools that an agent can call. 5 minutes? No freaking way. Okay, well, let's get into something and run something. So I actually already showed this, but if I do Flux run and 2 exclusive Python distributed Flux, this is, so by the way, what I didn't show you is shelling into the cluster and then connecting to the lead broker. I'm doing that, so this I can actually just show you from before. This was an example of running PyTorch with Cypher. How did we go through time so quickly? Let's see. I'm going to kind of jump forward a little bit. We're going to skip that. What I really want to do is show you some of the MCP stuff. We're probably not going to get to the trainer today. So let's get out of here. So I'll show you here, kubectl exec. IT is interactive terminal, PyTorch 0, and then bash. And so typically what you do is you source this file here, fluxview.shell, and then you can do flux proxy, flux socket, bash, and as I said before, now we can see flux resource list. So let's just YOLO. Oh, it's running PyTorch. Let's actually cancel that first because we don't care to finish this. Flux cancel all flux, actually flux jobs. Hey, this is running. Flux cancel flux job last. Flux jobs A. Wait, that's cancel. Okay, go back over here. Resource list. All right, we have our free nodes. So our tool is called Fractale. We're going to load this agent, and we're going to try to ask it to tell us a joke, and then load. Oh, I didn't load my secret, and it's right there. I tried to do that in a way so you wouldn't see my environment key. Okay, so we're making a request to the agent. Tell me a joke and parse the result for the punchline. You should use the parse agent step. If we look over here at the MCP server, what we would see calls to it. Hopefully we can interact with Gemini from here. While that's going, I guess we don't have time. We won't have time to do the trainer, but all of this will be on GitHub afterward because I think that's actually really cool to show you. I actually don't know if we're getting good connectivity from this cluster. Okay, so you're a sub-agent specialized at parsing tests and pass some of this. Okay, sure, go ahead. Okay, so I think it actually told a joke, but that was a really bad example. Let's run the harder example, which is actually going to use Flux, which is what I wanted to show. Okay. Discover resources, write a simple Python program that runs Flux across nodes, creates an archive, and then extracts files. So this is a hard thing I'm asking it to do. The joke is probably pretty stupid. Hopefully we'll have like a minute to run this. So what you're just seeing here is it called Flux resource list to see the resources that it has available. So it sees that it has those resources. This is an agent that's basically sniffing the environment and trying to discover what's there. So it's doing its next step. So what it just did is it wrote a file to the file system, and you see it's importing Torch. So it's doing some PyTorch stuff. Bytes written, successfully wrote that many nodes. Now it called Flux, this is going too fast. It called Flux archive create. That's creating an archive to basically share across different nodes. Okay? So now it's asking, is this plan okay? Run and optimize a PyTorch training script to minimize its execution time. So because we have no time, I'm just going to say yes. Normally you could say like no, and you could tell it like, I want you to actually do this differently, or that kind of thing. So let's see how it does. So it does flux exec. So here's an example of how it's actually going to learn about the different commands that it has. Let's see, train attempt to override existing file. Normally sub-agents will take a little bit of time to actually do that. Okay, it actually just created a database table for optimization results. It submitted a job. Okay, here's an error. Actually, I usually see this error every time, and in the past, it's actually fixed it. It submit the job. Okay, it actually just ran PyTorch. So what you just saw is that it wrote a script. It staged it across nodes. Now it's parsing the log for the results, and it would actually just keep going and doing this and optimizing this. So this is actually working, and in the beginning you saw the errors. We're probably out of time, I think, but I'm glad the demo amazingly worked. Are there any questions? What do you need? Oh, right.
What are the frameworks you're using for building these agents?
For building the agents, so we use a framework called Fractale, which is a simple framework that basically is based on state machines and comes up with sub-agents. If you watch my talk from Monday on YouTube, I go into it in more detail, and obviously, Hari, I can tell you about it offline. But there's other, if you want to use kind of off-the-shelf ones, there's LangChain, AutoGen. I don't use those because they feel very black boxy and they change very quickly, and I like total control and understanding what goes on.
Thank you.
Yep.
I think we're out of time and we're into your break. So.
Yeah, sorry about that, folks. Thank you for coming. I hope you liked the demo. Please come up after if you have questions.